Hello everyone. In this video, we are going to learn about a very interesting and important topic for HLD rounds, which is microservices versus monolith architecture. As a part of HLD interviews, this is a very common topic that is being asked in the interviews, and there can be a super tricky questions that can comes up when you are giving interviews there. So they can ask a kind of questions such as, how can we convert a monolith into a microservices? What are the disadvantages of microservices? What are the advantages of monolith? And vice versa. When should we convert an application from monolith to a microservice? Or they can ask, let's say I'm working in an organization or I have to build a project. When should I decide to move to a microservice? Like they can be any number of questions, and you will be able to answer all these questions once your conceptual understanding is clear with microservices and monolith architecture. And so we are gonna look into that. Now, when we say architecture, so basically these are both are architectures. So there are two architectures. One is microservices, one is microservice, and another is monolith. Now, monolith is more or less a legacy now. In most of the organizations and most of the projects, even in big banks, monolith is no longer being used. They have migrated to microservices. So if I have to if you have to understand that what is a monolith, just you can say that monolith is a legacy application. In this, all the functionality of an application is present in one single big box. So there is you can think about it as that in a monolith there is a one big server, and all of the modules are present in this particular same server. Like all the modules are in this. Like let's say this can be a payment. This can be a payment, right? This can be billing. This can be login. This can be authentication. Like all of the functionality is present in one big server in one big single application. This is what a monolith is, and this whole application will be connected to a one single database. So that's one thing. So this is one application. All of the functionality of this application will be inside this whole big box, and this will be a very big server most of the time, and it will be connected with a single DB server, and all of the transactions, whatever, all the things will be happening and managed by this single application. Now in this monolith, since it's a single DB, so it is usually better for faster transaction management because multiple applications doesn't has to wait for each other to respond. They can just have they can just go to the database and fetch the information because they only have one single DB. So all of the multiple application doesn't have to call each other to receive some information, right? Why is that? We will talk about that in microservices part. Now let's see what are the disadvantages. Basically, since it's a one big application, there are a ton of disadvantages for a monolith. Number one is it overloads the IDE. Now, what do you mean by overloading of an IDE? Overload IDE means since it's a very big project, let's say you are working in a bank and bank has a lot of functionality, portfolio building, portfolio management, transactions, billing, payments, refund, rewards, and all of that big code is present in one single app. So whenever you are importing that project or you are cloning that project from GitHub or any repository, it is gonna overload your IDE and will take a lot of time to load your project. So if you have worked in Monolith, so you already knew about it. Now, since it's a very big server, then another point would be scaling is hard. So basically there are two types of scaling, vertical scaling and horizontal scaling. In vertical scaling, you can only increase the size of the server. Means let's say if there is a server of 2 GB of RAM and 64 GB of, let's say, hard disk, then in vertical scaling you can increase the RAM, let's say, to 4 GB and storage size to 128 gigs. Basically you are increasing the specification of an server. Okay, and if you have seen in let's say in AWS there are lot of server classes, small, medium, large, extra large, but there is only a limit. You can increase a server size up to a fixed limit. After that you won't be able to scale it, you won't be able to scale it up, And that's why if an application overgrows that particular specification which is already maximum, then you won't be able to scale further. Whereas horizontal scaling is when you are increasing a number of servers. Okay, so in this you will just increase the number of server. Let's say you have one server with certain specification, you can just add one more, you can just add one more. But in vertical scaling you can just do what, there is this server, first this was server, and then you can just increase, let's say, the size of the server to this one. Let's say this is the maximum size, and after this you won't be able to increase its size further. Okay, so this is one limitation of uh, monolith architecture, that you are not able to scale it after a certain time. The another disadvantage of a monolith architecture is that while debugging you have to redeploy the whole project. Let's say there are these, you know, four modules in the system, sorry, in your application, and there is a bug in the payments system. So you fix it. Maybe you just add a null pointer fix, or you just add a condition if else, or you just add a logger. Now you had to make zero changes in these applications, right, in these modules, but you have to deploy the whole project. And this project may be, let's say, a very large, so it may take around 30-40 minutes to just get deployed, because there will be unit tests running, a lot of things in a pipeline runs when you deploy a server, or when you deploy a application. So it takes too much time and you need to redeploy the whole application. Since when you fix a bug, a regression has to be done by the QAs, right? Then it again takes a lot of time, because you have to then you have to run the regression for this whole project that includes these modules as well, that you really don't need to do the regression testing, because you have not made any changes. So you should always test this, but since it's a monolith, you have to do regression for all, so it takes a lot of time. And some there are manual regression tests as well, so it wastes a lot of time. Now let's say there is a huge demand of payments, right, or anything. Let's say a lot of accounts are being getting created, so which means out of this whole project only this particular module is getting a huge amount of traffic, but this server is not able to handle it. So what you will do, you have to scale it up, you have to move from this to this, but these modules will also be scaled up with this. Means you scaled up this server for this particular application, for this particular module functionality, but the resource, since it's shared resource, so some of the resource will be used and shared with other modules as well. So which means you are basically paying more money uh, for these modules that you didn't require to scale up, but you have to, but again, scale the whole thing up, and you have to pay money for this instead of just this. So this is one of the another disadvantage. And yeah, as we discussed already, a lot of time is taken for the debugging, because you really don't know from where the uh, bug arise, because it's a monolith. So you just know that something is wrong in the application, so you have to check via logs. You have to go through the logs, and you have to check a little bit extra. It will take a lot of time. Let's say if they were different services and there was an issue with this particular service, so you could just have debugged this one and fixed faster. But since you really don't know from where the issue arises, so you have to maybe check. Let's say you will start back tracing, right? So you may start from login, then you may go to payment. Like it depends, right? So it wastes a lot of time in debugging as well. Okay, now this is all about monolith for now. Let's talk about microservices. In microservices, this whole uh, big box, big application is divided into small services. Let's say there were four, so they will be divided into four small services. Let's say this is payments, this is logging, this is authorization or accounts, or uh, this is let's say notification. Okay, so these four will be divided into small microservices. So this whole application gets broken into this small chunks, and this is what we call microservices, and this is a whole application. So You get the idea, right? Now the all the disadvantages for this monolith becomes advantage of a microservice architecture. Since they are divided into small individual services, they were in whole, then debugging become easier because you can just debug a one single service. Component management becomes easier, and you can scale up a one single service. Let's say if payments are getting much more traffic, so you can just increase the size of this one instead of all these others. So you are basically paying money for only this, and they are still running normally. And since you are scaling a one single service at a time, or only the required services, so this is a little bit much pocket friendlier than monolith, where you have to basically pay money for everything, even if you don't need to. Now there are also some disadvantages of microservices. Let's talk about that. And what are the disadvantages? Now there is a very important point about microservices is like whenever you are decomposing, I mean when you are whenever you are converting a monolith into a microservices, or even you are starting a project and you decide to move on with a microservices architecture, then it's very important to break those microservices properly and in a very precise manner. In a way, like they should be loosely coupled. Loosely coupled means like this should be able to work independently. Same goes for this and same goes for that, this and this. Because if they are dependent on each other, if they are tightly coupled with each other, then there is no use of dividing them into a microservice. Then monolith is much better in that manner if you are doing a tight coupling, because if it may cause a lot of network management and it may also increase latency as well, because it will waste a lot of time just requesting or waiting for response from each other. That maybe, let's say, because they will have a different database, right? These microservices will have different databases in most of the scenario, and let's say this microservice needs some information from this services database. Now, according to microservice architecture rule, no service can touch a database of another service. It should always ask for the data from the next service instead of directly hitting to the database. So if it is not managed properly, then it will increase the latency because of this reason. Okay, which means if latency will be increased if we do not decompose this monolith into a microservices properly. Now we mentioned that debugging is easier, right? Because we know like which service have the issue, right? Because this service may go down or this service may have error, and we still know, like, because it will not build or it will throw error or that in the log. But there is also a possibility that this microservice is breaking because of this microservice means, like, by looking at the error, finding which component is the culprit becomes a little bit difficult, as clients of one component can break while services causing the issue run okay after an upgrade or release. Means if you are doing any breaking change, and let's say you have to use library, right? Let's say you have defined some APIs in this one, and you are using the lib or jar of this particular microservice into this one, and you have upgraded this microservice. Means you have defined or you have modified certain APIs, but this microservice will not know about it. So when you deploy this one with the new version, this will start breaking and you won't know, because this is working, this will be running fine, but this will break. So it might become a little uh, confusing at first, but I think with when you look at the logs for this particular service, you should be able to figure it out faster. But it's a kind of a mess sometimes, because when you have when you have decomposed something into a microservices, there is a chance that it will have a separate team, and it will have a separate team. So teams usually don't know much about each other, what they are doing, rather than they just talk with the libraries. So there's a possibility of uh, confusion in this one. Okay, now the very big disadvantage and a very important point as well for the interview perspective is that transition management is little difficult, as due to any failure, all child service DB activities required to be rolled back. Which means, okay, means let's say you have an service, you have an account service, right? And for account service, from account service you are managing user accounts, and this is a payment service. So when you are doing a payment, so you have to make some changes in this payment service, and you have to make some changes in the accounts service as well, in the databases of each service. But while you, let's say you are, while updating the payment service or while updating account service, it failed. Now what you will do, you have to roll back database transaction for this one and as well as this one. And how we will do, we will talk about it as well. But it's a hassle, because it will become a little harder to maintain or manage that DB transactions if multiple database needs to be updated for a single call or a single task. Okay, so these are some of the basics of microservices and advantages and disadvantages. Now let's talk about microservices in detail. Like, what are microservices in detail? Let's talk about that. Now, whenever someone asks you that, hey, let's convert a monolith into a microservices, then how micro? Like, what should be the, what should be the decision point? What should be the criteria? What should be the steps that helps us to decide, like, in that how micro those services should be? Okay, so so to decide that how micro those services would be, there are certain patterns that helps us to decide there. Because if you see this microservices, they are made up of two words. One is micro, which means how micro, like how micro those services what, and then another word is services. Okay, so we need some patterns to decide on this particular part, like how micro those services should be. How micro? So there are some phases that we follow that are given to us in order to figure out how micro those services should be. So we have certain patterns. So one is decomposition, another one is database, and we have communication, we have integration, and so on. Like, there are a lot of phases that usually follows, and these all are needed to be done, let's say, in order. So decomposition is one of the design patterns of microservices design pattern. Now, okay, so these are also these are phases and patterns that are used in order to decide how micro our service should be. Now, another fun part is, like, these specific patterns are further divided. So in decomposition, we have two types. One is decomposition by business capability, and another one is decomposition by subdomain. For databases also, there is something called, should we go with DB per service, or we should do share DB across all services. So we have to decide on this as well. Then for communication also, we have to decide that should we do communication via APIs, or should we do via events or some other way. So they can be anything. Then again, there are like lots and lots of phases, there are lots and lots of steps involved in order to decide for one single microservice. And there is a possibility that you may decide one should follow this decompose. You decide, okay, we will decompose it by business capability. Then you have to decide that should this microservices be DB per service, or should we share among all services. There can be a combined approach as well. Then with communication, we have to decide, like, should we go with APIs or should we go with events, right? Events mean Kafka or RabbitMQ kind of services we should use, or we should go with something different. Then we decide, like, how should we integrate it, right? Should we do API gateways? Like, what things should we integrate? Like lot of things out there, like, because you have, when you create a microservices, then you have to do integration as well, right? So it contains a lot of points. Then after this, we have observability, then we have monitoring as well. Like, lots of points comes up. So just make a note of it. I just understand about this particular part of the video, that whatever we have discussed around microservices, then how micro. So all of this that we have discussed just now is are all phases that are needed to be gone through in order to create a microservice. Okay, now let's start with the very first pattern, which is decomposition pattern. Okay, now definition wise, we can say that this helps in deciding how small we need to divide a monolith app into a microservice. Okay, now in decomposition, we saw there are two types. So I can just take this one, right? So we saw there are two types. One is by business capability and by subdomain. Now, when we are talking about by a business capability, so we will understand it by an example. Let's say we have an online order application, okay, and since it's a business capability, so what are the business capability of an online order application? So it has, let's say, order management. Okay, let's say we have product management. So these are all business capability of this online order application. So we have account management, then we have login management, we have billing management, then we have payment management, then we can let's say accept and accept, right? We have like all these are business capabilities. Product management is nothing but inventory management, you can say. Then we have billing, because when you are making an order up to order management where you can place order, then you will manage entry for that product, right? That you then you will manage accounts, then you will also manage the billing. So billing may be of, let's say, the item you are selling, so you will do the billing of that particular item, like how you will manage the billing. Then it will have the payment also, because you will be paying something, right? So you will receive payments for that. Now what is the challenge is this one, because of course you need everything you do, there is a certain point you need to take care of, and there are certain challenges you are dividing or decomposing a model by business capability, which is that you should have knowledge on your business functionalities, then only you can determine the business services. Because if you don't know the business capabilities, then you won't be able to really divide your like the question we are like how micro a service should be. There is no scale of measuring that in any way, because for some micro can be this much, for some this much, this can be a micro, for some businesses this can be a micro, even, and for some even this much can be also a micro, right? So it depends on business to business, like what is micro. If the business is smaller, then definitely this might be micro for that, right? If business is a very large amount, then they might have to divide it into a even smaller pieces, which can be, this can be a micro for them. There is no way of measuring a micro, that depends on business. Now moving further, we can talk about a decomposition by subdomain. What does it the decomposition by subdomain mean? And we can take the same example. Now this is a business capability, which means this is also a domain, right? Order management can be a domain, which means one module can be huge in itself. So to divide that even further, we use divide by subdomain pattern. Okay, as we said, like for some people this can be micro, this can be micro, and even this can be micro. But let's say the product is super huge. You are working in a bank, and bank has tremendous amount of things going on parallelly. They have thousands and thousands of employees, sometimes lakhs of employees, and which means they have a tremendously divided uh, domains. They have a divided business, so they need even, which means they need even more granular level management for their products. So this becomes a domain for them. Now what can be the subdomain for this one? It can be anything. It can be order tracking, or it can be placing. It can divide one service. Under this domain there can be a placing service that only does what? Order placing. Just you are placing order, because you are getting tremendous amount of orders. That's like Amazon is a very huge marketplace, so you may be getting millions of order placed worldwide, so you need a separate service for order placing. Now once you place the order and order is confirmed, then you need to give order tracking ID to the user. That can be a whole service into it, where you integrate Google Maps. Some people somewhere in some other country you may integrate Apple Maps or whatsoever, right? Even multiple data centers are there. Like it really depends on the size of the product. So order tracking can be one thing, right? So it can have multiple microservices, so you divide it into two. Then maybe in payments, payment is one of the domain, right? So it can be payment forward, means you are basically doing a payment normally, means user is paying you. Okay, you place the order, then you do the payment, right, which is payment forward, right? You are paying the money, the user is paying the money. And another subdomain of this one could be refund. Someone returns something, someone cancelled their order, then again it will be go on, or cancelling order may go into order management and some other service. And then once it's done, then you may have a totally separate microservice for a refund where only all the refunds are being managed. Okay, so it really depends, as we saw that some micro can be for someone this, and for someone this can be micro, and even someone this might be micro. So I hope you understand what is the difference between a microservice and a monolith. Important points that you need to understand. If you have any queries, please feel free to comment down, and I'll respond as fast as possible. Thank you. See you in the next one.